Ladies and gentlemen, welcome back to Engineering Dynamics. In this video, we will be talking about transformation matrices on how to get from one coordinate system to another one, and about absolute and relative velocities. So let's jump right in. We are given this example. So we have a point P that is oscillating, and we have a rotating disk, of course. And now what we want to find out is the velocity of our point in the inertial coordinate system. So we have an inertial coordinate system right there, and we have a rotating coordinate system k that is right here. We are given the vector of r, so we have a constant that is a, and this is our wiggly part, so our oscillation. What we need is the velocity, and we know that if we are in an inertial coordinate frame, we can just derive it with time. So we need to find that out. The first thing we need to do is, of course, find r. So to get r, we need to transform our vector r that is in coordinate system k from k to I. And this is done by the transformation matrix that is transforming from k to I. So to do that, I'll explain for one vector. So we take the unit vector in x of our coordinate system k and see how it is described in I. So here we have, again, the angle. So we have a cosine theta in this direction, and we have a sine in this direction. In an analogous way, we get it from y, and for y, and nothing is happening in z because we are rotating around z. So now we know how to get our vector by a simple pre-multiplication. We have always to pre-multiply it. So we know our vector r in the inertial coordinate system. If we derive it, we have to derive it, of course, we have here a time component, and we have our angle that is a time component, and we get this lengthy expression. This can be done in a different way by getting first the acceleration of the point P in coordinate system k, and then transform it from k to I. So if we look at the velocity, if we have the vector that we are given, we can't just derive it once with time and say that is the velocity. We have, again, to use the rotation part. So because if a vector is moving, it has a rotation that we need to consider. If a point is moving, sorry. So we do that by deriving it once with time and adding the rotation. We have here our vector that is simply derived with time. Then we do the cross product of our rotation speed, of our angular speed, and what we get is this one, because here's 0 and 0. Here we have theta dot times this one minus 0, and here we have 0 and 0 again. So by adding this one and that one, we get the velocity of point P in coordinate system k. And now we can get the velocity of point P in coordinate frame I if we transform the velocity of point P in k from k to I. And we do this with the transformation matrix that we had here before. So we multiply the matrix with a matrix, and again get a matrix. So we multiply the first part with this one, and get that. We multiply the second part with this one, and we get that one. And we see that both of them are actually the same thing. We have this one right here, and this one is right there. I hope this video gave you a small understanding on how we are working with different coordinate frames and how we transform from one coordinate system to another, and that we have to consider the rotation parts of the cross product of our angular velocity and our vector if we are not in the inertial coordinates in the inertial coordinate frame. If you have any questions, put them down in the comments, and I will do my best to answer them as quickly as possible. Thank you very much for your attention, and see you next time.